Ethical implications in emerging IoT technologies. What exactly is IoT? IoT stands for the Internet of Things. It is an emerging technology that enables interaction of uniquely identifiable computer devices that can be embedded with other interfaces like machines and humans via wired and wireless networks. IoT allows for any device to take place over the existing internet infrastructure. As depicted by the chart, IoT has gained popularity over the past decade in providing new digital business models and services within the home, classroom, and travel industry, all of which this presentation will discuss. Gartner, a worldwide research and advising firm for businesses in IT, finance, HR, customer service, and support, has predicted that IoT sensors, devices, and systems will grow to 20.8 billion units by next year. IoT has drastically affected the way we communicate and access information. But however, such advancement does not come without a cost. Such increased application of IoT involves issues relating to privacy, security, in the following areas, such as smart homes, smart tourism, and smart classrooms.
For the purposes of this research, a smart home can best be understood as an ecosystem of smart objects providing services. These services are inclusive but not limited to safety protocols, environmental control systems, communication applications, energy control systems, and entertainment applications. A discussion of notable capabilities and specific ethical limitations of these smart home objects continues to emerge within the integration of IoT technologies. A notable goal for the application for smart home products and their environments are to remain as unobtrusive as possible while providing interactions of data that are meaningful to users. Smart home technologies have yielded an active participation in the healthcare community in regards to at-home safety benefits. The peaked interest in smart home technologies is present in efforts to promote living alone independently as the increasingly difficult challenges of maintaining mobility and cognitive functions arise in the older age community. The technology-assisted friendly environment for the third age group captured in an unobtrusive dynamic that monitors the health and well-being of older adults, incorporating sensory technologies through integrated systems that develop a process for communication and extraction of information. The Taffetas Smart Home Research provides an independent living apartment laboratory. The image furthest left displays the bedroom, restroom, and kitchen areas of the laboratory. The model includes thermistors to the bed to provide body temperature gauges and accelerators on chairs, couches, and flooring throughout the apartment in order to gauge when an occupant might be losing balance or falling. RFID tags are proposed to be attached to commonly misplaced objects around the house. Infrared motion sensors can also be installed in each room to detect unnatural motion patterns. In addition, microphone arrays are mapped to transmit the sound within the residence to monitor a station. This process can be useful to detect abnormal noises or calls for help by the occupant. Smart grab bars can also be placed in the most evident areas in which the occupant might be in need of assistance, for instance, showers, kitchens, toilet areas, etc. The advantages of the Taffeta proposed independent living apartment laboratory grounds itself in providing a reasonably natural standard of living alternative promoting autonomy and self-sufficiency. With that being said, it is important to note that a lot of these technologies are still in their developmental stages, so much so that the ethical dilemmas for securing the data that is retrieved from the smart home environments is still a privacy concern. In addition to the privacy issues, architectural designs also pose an ethical threat, as some researchers believe that the decision on what data to share should rest with the architects rather than the end users themselves. The argument is that knowing what data is shared or results of how their data is being tested could lead to an occupant thinking they no longer need assistance based on the success of the smart object aids, and thus rejecting future treatments. Contrarily is the idea that occupants become completely dependent on the automated reminders that they can no longer perform simple tasks, in turn exhibiting forms of regression. Nevertheless, the usage of sensory data and data management protocols remains a topic for continued research and discussion.
What exactly is smart tourism? Well, smart tourism is a new form of tourism based on the application of IoT, cloud computing, and other modern technologies in the tourism experience. Smart tourism is a major player in the evolution of information and communications technology in both the physical and governmental dimensions of tourism. And as depicted in the images below, it is built on the basis of smart cities, such as intelligent hotels, which is depicted on the right, where you're able to open your door just by means of a code on your phone, smart transportation, smart services, and smart managements. Airports are notorious for long lines, misplaced luggage, and changing flight times, all of which IoT has successfully been able to address. With automated machines, travelers can easily check in and obtain boarding passes, therefore drastically reducing long lines at check-in counters. Many companies, as the ones depicted below, such as Delta Airlines, Alaska Airlines, have employed IoT into mobile apps to help travelers book, manage trips, change seats, and much more. In an attempt to reduce misplaced baggage, Delta Airlines has implemented the use of RFID bag tags to provide customers with real-time tracking of their bags. According to a study conducted by the International Air Transport Association, also known as IATA, it's found that a global RFID solution could have the potential to reduce the number of misplaced bags by 25% by 2020, and therefore saving $3 billion over the next 7 years. And although RFID tags have proved to be very beneficial to both the customers and the companies involved, it does have a considerable amount of ethical trade-offs in the sense of privacy. Unfortunately, RFID tags are able to respond to any reader, authorized or non-authorized, and this all happens unbeknownst to the owner. If found in the wrong hands, malicious individuals can begin to track and profile individuals.
Another IoT-based system is the Smart Classroom. Smart Classroom essentially takes a classroom and makes it interactive, and it can use an array of sensors. There is two classrooms that I talk about here. One is an interactive classroom where a teacher can use an IoT system to judge a student's attendance and also help with their education and encourage students to get better grades. The second application is a smart classroom where the IoT system will judge the behavior of an audience and help a teacher or a lecturer make a better lecture. It'll essentially use that raw data to tell them how people are looking at this lecture, how everyone's behaving because of it, and they can adjust it accordingly. The first application is the one I talked about where it's encouraging a student to be better behaved and to attend class more. It does this through two separate functions. One is a QR code. This QR code can be used in two different ways. It can be used to be scanned and it'll show a video. This video is a supplementary video to the current course content that a student is doing. This allows a student to extend their learning and look more into their topic that they're currently reading over. It also allows a student to actually go out and look at other topics ahead of time and watch videos on that. A student could also just go ahead in the course, eventually complete all these videos, and have a better understanding at whatever pace they want. The other way a QR code is used is to distribute questions. These questions are essentially like polling questions. They're questions that involve the course material, and it allows a teacher to look at the answers of these questions and the percentage that got it right and adjust the class accordingly to cater to the people who don't understand anything yet. And then the teacher, of course, can adjust their lecture, go over a topic again, or go more in depth of it to make sure their entire class knows what they're talking about. Another thing that's used in the system is an RFID card. Now, these cards are swiped when a student first goes into class. When a student first goes into class and swipes their card, it's used to take the attendance. And the card is also used to monitor a student's behavior in class. It's an application that uses an IoT cloud-based system that essentially allows the teacher to have full monitoring of the class in these aspects. Now, one of the major problems with this is a teacher could go further and go against what the purpose of this application is, because this application is mainly meant to encourage students to learn. But a teacher could go further and just grade the attendance, grade the people who watch the videos, grade the problems that they give in class with the QR codes. They can essentially monitor the students and use all these as grades or checkpoints instead of just using it as a way of encouraging studying and learning. Now, this undermines the purpose of the entire application, which is to encourage learning among students. Lecture. It does this so it can help a lecturer or a teacher with their lecture quality. It does this by looking for movement and by looking for interference with sound. If students are talking, if the lecture is too low. It does this through PIR sensors, which are sensors that detect movement using a 0 or 1. And whenever a student moves, it'll just shoot off a 1, so a teacher will know how many students were moving during certain parts of their lecture. And then there's a microphone that basically listens into the teacher's lecture, the tone of their lecture, and if it's at a certain pitch or if there's other sounds, make it at a certain pitch. A student could be more unattentive and lose track of the class. There's also a camera that constantly takes pictures of the students just to see the movement, see if they're fidgeting around. It does account for if a student stands up, goes to the bathroom. It only really looks for the minor differences to see if a student is fidgeting and not paying attention. The last one is the sound sensor, which is the overall sound of the actual lecture itself. Now, this is to look for background noises, to see if there's students talking while the teacher is talking, essentially interfering with the class and just degrading from the entire lecture and the studying in general. Now, this IoT system also uses the cloud. Now, it just gets all this data and spits it out to a user to observe. So essentially, the user, being the teacher, can look at all this graphic and analytic data over their lectures and see what times in their lectures the students are stumbling or not getting and adjust their lectures accordingly. Now, an issue with this system is the sensors can't always gather the most accurate of data. Like the PIR sensor is only using 0s and 1s. So a student could move maybe a little bit or maybe not at all, and maybe the sensor would still go off. Now, these misinterpretations of the sensors will go back to the teacher, and then the teacher will not know really how to properly adjust their class. The other problem is that these sensors record pictures and essentially conversations of students. So it's a big privacy violation. It'll have pictures of the students, every noise they make. So essentially a teacher could listen in on a student's conversation even if it is personal or private, which if this doesn't get approved by multiple people, it can lead to outrage and it can lead to even legal pursuits against the school itself for a teacher using this kind of system. So with this entire PowerPoint and with our entire actual project and our term paper, we talked about 3 different IoT systems. Now, the biggest issues with these IoT systems is privacy and security. With privacy, they can easily invade someone's personal life, learn about them, allow people to get that recorded data. Then with security, some of these sensors and some of these IoT systems don't exactly work, or they aren't exactly secure. Someone could easily hack in and get a person's data, which is why with these growth in IoT systems that we need to be prepared for what the future may hold. This is why engineering students need to know how to properly do an IoT system while keeping in mind the user's privacy and their security.